Hello and welcome. In this video I will talk about my road bicycle build that I'm trying to build for myself according to my preferences, and I will also mention some standards in bicycle industry today, the pros and cons and the problems that I see. I have already written a long and detailed article about buying road bicycle buying tips. If I don't forget, I will make that article pop up in your top right hand corner so that you can click on it and read it. And here I will just touch up on some of things that I've mentioned there while I'm talking about this bicycle build. And so let us now begin. In the video I'll make chapters like table of contents so that you can skip to the parts of interest, because it's probably not going to be a very short video. So this first boring part is called introduction. Now let us begin the frame. A good analogy for a bicycle frame is that it is both the spine and the heart of a bicycle. Why? Because the frame practically mostly affects how a bicycle handles and what you can mount on a bicycle and what you can do on a bicycle to a great degree. And it is also a thing that when you need to replace, if you don't find exactly the same model with exactly the same mounts and standards, you might have to replace many other parts. So it is of crucial importance, and this frame that I chose for this bicycle is made of aluminium, and the fork is made of aluminium. It uses a threadless stem, the modern threadless stem, which is more secure because it's held in place by two bolts compared to the old quill stems, which is my main objection to old style bicycles. Everything else is, as far as I'm concerned, quite good. This is probably one of the last inventions in the cycling industry that was aimed towards helping the user and not helping the sales and mechanics. This last part is also not always true, as we'll come to that. So this is made of aluminium. I prefer frames that are made of steel or aluminium because I can see any cracks on the outside and react in time. And carbon fiber frames and forks, on the other hand, you may get the lamination of the composite materials layers below the surface, and then have it crack when you do not expect it during a ride. Some parts that are facing more stress, more torsion and twisting may become more flexible, so you may notice by the frame becoming a bit more flexible, but sometimes you may not notice that until it's too late and it cracks during a ride, and I'm not very fond of that scenario. So that is the reason why I personally avoid carbon fiber anything on a bicycle. And other things that I like about this frame, I've made a separate video explaining the difference between the modern trend and the old style frames. If I don't forget, I'll make that video also pop up in your right hand corner. But here we don't have any internal cable routing, so I don't have to fiddle the cables through the frame. I can see if there's any problems, any fraying with the not the wires but the cables and the housing as well. So it's very quick and easy to replace anything on a frame like this. And other options that I like is that it has quick release mounts, so open dropouts, and I prefer that system to those modern through axles, as they are called, though I think technically those are not axles at all, but nonetheless for disc brakes they are a must, because disc brakes mounted on the rear side of the fork tend to try to pull the wheel out of the dropouts downwards when you're braking, and that is why quick release systems are not safe enough to use with disc brakes, in my opinion. But otherwise, for bicycles with rim brakes, they are the best invention ever, because they are self-securing systems. As I'm trying to open this, I need more force to move it to this place than I need to get it back. Only past a certain point it becomes more easy. So they are like self-securing. I've made a separate video about quick release, so I won't take too much time on that, but it's a very quick and easy way to mount and dismount wheels, very practical. I don't need any tools, and it's inherently safe, self-securing system, so I love it. And I think I've covered most things about frame. Oh, of course, the rear chainstay length is not very short. This is almost 45 centimeters, so that effectively puts me almost between the two axles, not sitting on the rear wheel practically, so I get a more comfortable ride. Just like you do if you sit on a bus between the two axles, and not in some seats that are on top of the axle, especially in the rear. Or if you sit on a motorbike on a pylon seat, you will often get a bit more bumpy ride, a bit less comfortable compared to sitting in the front, because that position is more between the two wheels. So that is the basic principle and the knowledge. I hope it's a good one. Another advantage of having a longer chainstays is that I can mount a rear rack. This frame has rear rack mounts, and I can mount panniers without hitting them with my heel as I'm pedaling. And also that makes for a bicycle that steers a bit better on fast descents, at least in my opinion and experience, as is everything that I say in this video. So I think I've covered all the high points when it comes to the frame and fork. Now let's talk about wheels, because after the frame, wheels are the next most important thing for a bicycle. If you have good frame and good wheels and decent brakes, you're good to go. Everything else is not really important unless you're racing. Shifters, derailleurs, all that stuff, as long as it works more or less good, you can go. So when it comes to wheels, I wanted to use wider tires. I made sure that the frame can fit at least 28mm wide tires, because life is better that way. It gets me a more comfortable ride on bumpy roads, and there are minimal disadvantages compared to using the narrowest tires like 23 or even 25mm. So for me it's a best sort of a trade-off. I did not want to use tubeless tires. Tubeless tires have some advantages. I'll now briefly touch upon those. They allow you to ride a bicycle on a very low pressure, and if you hit some bump, the tires with tubes get a thing called pinch flats or snake bite flats, because as the tube, when it's very low pressure, hits the rim, it will squash the tube at two places against the rim sides and tear it apart. So you will have two relatively large holes relatively near each other, and that's practically impossible to fix, to patch, and the tube is toast. So to avoid that, tubeless tires don't have a tube, so that cannot happen with them. That's one of their advantages. And another advantage they have is that if you get a puncture, because they require a special like a lube, a special sealant that is liquid, that is poured into them, that sealant will in contact with the air get a bit harder and effectively patch the puncture, unless it is a big puncture. So that is another advantage of tubeless tires. And the third advantage is they are a bit lighter because there is no tube inside. Even though there is the sealant liquid inside, there is no tube, so it's in the end you get a bit lighter setup. And now why are they bad? Why I don't like using them? First of all, for road bicycles, running at a low pressure makes no sense. Low pressure is used for very bad terrains to get better grip and better traction, but I would never ride a road bicycle with tires that are very deflated. Also, because of the high pressure, and because unlike with cars and motorcycles, bicycle tires need to be very supple, very easily bent and straightened up to reduce rolling resistance and weight. On high pressure, relatively narrow tires for road bikes, they are very difficult to seal properly, and there are a lot of problems. There are problems also on mountain bikes, but on road bicycles it still looks like a work in progress and hit and miss. That at least is, again, my opinion. So the option of them allowing for lower pressure is unimportant for the road bicycles, and also the minimal weight reduction for me is completely irrelevant. And the self-sealing option, if I have problems with punctures, I will go with puncture resistant tires. But I've already made a video about how to reduce punctures, how to avoid punctures. I'll make that video pop up when I'm uploading this. If I don't forget, there are better methods, at least for me. And the problem with sealant is that it's not perfectly reliable. It will not always work. It will not patch a larger cut or a puncture. So you still have to have a spare tube just in case, then remove the valve from the rim and mount a tube to limp home, and it's all a mess when that liquid comes out. And in order to inflate those tires when you mount new ones, or you fix a flat or patch the tire itself with some patches or something, you need a lot of high pressure to have the tire seated against the rim, because there is no tube to hold air. So a lot of hassle, a lot of complication, and for me, for road bicycles especially, it's more of a problem than a gain. For mountain bicycles, maybe. I don't use it either for those, but maybe. But for road bicycles, I think it's nonsense. Then let's move on. Now the next thing, we'll talk about our brakes. I prefer using rim brakes because they are lighter, simpler. Disc brakes have a problem that they are the scratching, the rubbing is an inherent problem of the design, because they need the pads to be very close, since we are using on disc brakes a relatively small disc, and we need to have a huge mechanical advantage to be able to brake using a very small disc. Even 180 or 205 millimeter brake discs are very small compared to a 620 millimeter large disc that rim brakes use, which allows us to get a better pad clearance and no worries about rubbing or anything. So for this, for road bicycles, the options for brakes are mini V brakes that have relatively short lever arms, so they work with standard road bicycle levers. Or you could use cantilever brakes that also work fine with road bicycle levers. So those are the options for those. I have opted to try and source mini V brakes because I find tuning them to be a lot faster and simpler. But if I don't manage to source any, I will use cantilevers. I have some old as a backup. And another thing I want to show, these are the Shimano mini V brakes that were made with 9 centimeter long brake arms instead of 8 centimeters. So they require a lot more cable pull, and they only work with the newest, latest and greatest Shimano shifter and brake levers, SDIs. And so they managed to make mini V brakes that don't work with standard road bicycle brake levers. That's a great feat. And so I risked with these, gave them a try, and the effect was that I had to set my brake pads to be less than 1 millimeter away from the rim, and still it took almost the complete travel of the lever in order for the brake pads to reach the rim. And when they do, I would get a huge mechanical advantage of braking, but I don't feel very comfortable having the brake pads too close to the rim. I don't like that. I want some clearance. And so this will be sold to someone who uses the modern brake levers, and now I will get to explaining why I do not. Alternative is to use cantilever brakes. For that, on this bicycle I would need an adapter like this to mount it instead of one of these rings and compensate for it, because it has a housing stop, and cantilever brakes require the brake cable to come from the middle, so it requires a housing stop and then a cable. So that's the plan B, to use some cantilever brakes. These ones I have are a bit fiddly to set up properly. I don't really like this system too much, but the biggest problem is that I cannot find spare pads in my city, in my country, or for that matter even quality high quality whole system, whole brakes, not just the replacement. So it's that is the limiting factor for me, and why I will try to give it a week or another week or so to try and source the proper mini V brakes. Tektro makes those 8 centimeters long and they work okay. So now let's talk a bit about the drivetrain, to bore you with that before I get to the shifters. This is Shimano Freehub that can take from 11-speed MTB cassettes up to 7-speed cassettes with some spacers added behind. And I love having that flexibility so that whichever cheapest cassettes comes by, I can just smack it on and use it. And with the 7-speed cassettes, they usually are the cheapest. I can also use any chain that I find at a decent price from 7 to 10 speeds. That's what I've tried. Haven't still tried using 11-speed chain on a 7-speed cassette. I have also articles about that compatibility and what can be mixed matched. As for the cranks, this is a threaded English bottom bracket and a square taper cranks with steel chainrings that should last very long. They are a bit heavier than aluminium but last very long. And this is modern compact cranks. I found this for about under $20 new, so I couldn't find at the moment any, any triple cranks, and I didn't have any triple derailleur, so that is one of the reasons why I went with this setup. This is the modern compact crank standard that uses 50 teeth on the larger chaining and 34 on the smaller. Now that for me is not the perfect option. I used to ride, I still have those cranks, Shimano BioPace cranks with 53 larger chaining and 42 smaller chaining. So I'm not getting any younger or fitter. So for me the 42 chaining, smallest one, was too hard to ride on very long steep climbs, and I decided for this build, okay, it's enough. For me, that's the last time I did a climb, I had to go zigzag in order to reduce the incline artificially. I just couldn't pull it through after several kilometers. It's too much for me now, and so I decided to give up and go with the smaller cranks. However, what I don't like about this is that the 34 chainring is too small for anything except climbs, while 50 chainring is not very good for me for riding in small inclines or with a lot of headwind and things like that. For all those options, I would have to move the chain towards the middle of the cassette, so 16 or even 18 teeth on the back. And that would mean that the chain would be very crossed most of the time. I would have preferred if I could find combination of 30 and 46 cranks, but those are not available, and the ones that I could find cost an arm and a leg, and so I gave up on that. And I'll see how this fares in practice. I am not very optimistic, especially because no longer could I find shorter square taper bottom brackets and axles. This one is 110 millimeters, but for this setup I would have preferred even 103 millimeters or a bit longer, to have this moved a bit more inward. There is enough clearance so that when I'm on the middle of the cassette, the chain is not at a huge angle, not cross-chained, so it lasts longer and there's less mechanical losses and less rubbing and noise and everything. But we'll see how this fares. When it comes to derailleurs, I had this and I used it. It's a decent Shimano Diore MTB derailleur. This is some very old Shimano RX100 front derailleur. I think it's older than me even, and it still works very good. And for the shifters, my preferred option is to use these. These are called down tube shifters. I'll just get all the parts, all the bits and parts to show it. These are down tube shifters. They are mounted using this at the down tube for steel frames. This aluminum frame has a tube that is too thick, so I would have to find a way to take out this mount. These are over 50 years old, by the way, and they still work great. So I have to find a way to perhaps weld this or cut out and weld this whole section to a larger mount and somehow improvise. And so for now I didn't want to go that route, but that's my preferred option because down tube shifters are safe from any bumps and hits. When you fall, they generally don't break down, at least in my experience, so I'm quite happy using them. And here let's try to put this one together. It's a very simple mechanism and there is nothing to break down on it practically. This is all there is to it, so that's what makes it very durable in practice. Okay, it's all set now and good to go, and that is what I love about this system. However, as I said, for now I will not be using those. And what is the currently modern standard is this. These are called STIs or shifter, Shimano, whatever the acronym is for, I forgot, sorry. But it combines shifter levers with brake levers. There are different patents, but they all share the fact that there are many plastic parts very sensitive inside, so they generally aren't serviceable and it's next to impossible to source spare parts, at least in my city and country. So I've had these fail even when they are new without any prior warning, so I'm not a huge fan of these. And they are quite costly and not very durable, so it's a lose-lose as far as me as a cyclist is concerned. So I don't really enjoy using these. I prefer more sturdy options. And so what I wanted to try on this frame, instead of trying to mount something that would probably look ugly on the down tube, there is option made by American company called BikeGremlin. I think I've pronounced it properly. They buy Tektro brake levers that are of decent quality and cost about $20–25, and then they machine a mount for friction shifters, down tube friction shifters. They machine a mount so that you can mount something like this to stay on the front of your brake, and so it's you can easily reach it from the hoods or from the drops and make shifting. So that's option that looks very promising to me. I've heard that it's quite durable and good, because there's no reason why it shouldn't be. Those Tektro levers are okay, durable, strong, and they have spare rubbers relatively cheaply and it's still available. And friction shifters, down tube friction shifters, are indestructible. However, those things cost about $200 and some to buy, and with the shipping costs and our import taxes and all the other VAT and other taxes, they would end up costing me probably just around $400 by the time they reach my garage. So that was not an option for me. So I decided to use these. These are called bar end shifters. They are using the same mechanism as those down tube shifters. They just have a mount that screws into the hollow part of your bars, and they also can work in friction mode. So whatever combination of cassette and chain or derailleur I use, they will work, and I love that simplicity, and I hope these will be durable, or at least as durable as these. These have lasted for over 50 years, and these, I hope they will last at least 5. I'm sure Shimano have improved. There are some more plastic parts inside now already, so we'll see. I'm not really optimistic, and I'll see if that fails to try and mount those onto these metal holders. So I think that could also be an option. We'll see. I'll think of something, but first thing is to get the brake levers, and then I'll make my bicycle a test ride and see how it goes. And I think that's about it. I think I've covered everything. And it's fair to note that these STIs, they are the most ergonomic option. There's no arguing that. Most practical to use when everything is not new and well tuned and nicely working. but these combinations are, in my opinion and experience, a lot more robust, a lot less likely to break down, cheaper to replace if they ever need replacing. So that's why that's how I roll. Life is better that way. And I think that is the whole video. I hope I've covered everything. If you have any questions or additions or criticism, use the comment section below. Of course, don't forget to like, share and subscribe. We have to beat the dripping faucet as the most boring video on internet with most views. And thank you very much for watching. I'll see you in some other video, hopefully on a finished bike in a week or so. Cheers!